I'm going to go through some select problems on solving polynomial equations. So in number 2, we're asked to solve the polynomial either by grouping or quadratic form. So that's a hint that one of the two methods is going to work. Since this is 3 terms, clearly grouping is out. It would have to have an even number of terms. And it's pretty straightforward to recognize that this is a constant term. We have an x squared term, then an x squared term squared. So again, like before, I'm going to try making a substitution if you find this helpful. So pick another variable. You could call it s or a. Let s be x squared. When we do that, then we'll have 2 times x squared squared plus 3 times x squared minus 20. And we're going to replace those x squareds with an s. So we'll end up with 2s plus 2s squared plus 3 times s minus 20. And that equals 0. So now this looks like a normal quadratic, and now we can factor. So we have to also factor 2s squared as well as the number at the end. 2s squared, the only way to factor 2 is 1 and 2. So we have 2s times s. Now I need to guess and check factors of negative 20. We need to add up to 3. So I'm going to guess 4 and 5. I want to add up to positive 3, so the 8 should be bigger than the 5. So do plus 4 and minus 5. Now I can go ahead and substitute back in x squared. So this becomes 2x squared minus 5 times x squared plus 4 equals 0. So now at the end, you would set each factor equal to 0 and solve for x squared. So I'd have 2x squared minus 5 equals 0. So 2x squared is 5, so x squared is 5/2. So at the end, I take the square root of both sides, and I would end up with x equals plus or minus the square root of 5/2. For the other side, I'd have x squared plus 4 equals 0. So x squared is negative 4. And now when I take the square root of both sides, I would get x equals plus or minus the square root of negative 4. So again, imagine that negative comes out front to become an I, and then the square root of 4 is 2. So basically that should be 2i. Looks a little weirder if you put the I first, so say x is plus or minus 2i. It's the proper way to write it. And we also had x is plus or minus the square root of 5/2. So those are our solutions, and there's 4 of them. Number 3, we again have to solve by grouping or quadratic form. Right away, since there's 4 terms, this is not going to be a quadratic. So that's a hint that grouping is going to work. Now to solve this, we want our equation to be 0. So we need to move all the terms to one side so that you're left over with a 0 on the other side. Otherwise, factoring won't help at all. So let's bring everything to the left. That way, I can keep the leading coefficient on the leading term positive, so bring it to the left. And then negative 8x becomes positive 8x, 12 becomes negative 12. And then I get equals 0. So we're going to use grouping, which is sometimes called the box and circle method, because you can imagine drawing a box around the first 2 terms and a circle around the last 2. Now in the first 2 terms, we look for our GCF. The GCF between these 2 is going to be an x squared. So pull out an x squared, write what you're left with inside. 2x cubed divided by x squared is 2x. Negative 3x squared divided by x squared is negative 3. Now I go to the next 2 terms and look for their GCF. 8x and negative 12 would have a GCF of 4. So pull out a 4 from those 2, and let's see what we're left with. 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. Now, if you did this correctly in a problem that you know should work with grouping, what's left over should match. If you notice that the signs are different, that can be a hint that you probably should have taken out a negative with the GCF. So now the next step is I imagine pulling these outside. When I pull the 2x minus 3 out front, I'm left over with the x squared plus 4. So that's what goes in the second set of parentheses, x squared plus 4. And this equation equals 0. And now since I'm multiplying things and they're 0, at least one of them has to be equal to 0. So we'll take each set of factors, set them equal to 0, and solve. So we would get 2x minus 3 equals 0. So 2x is 3, or x is 3/2. And we'd also have x squared plus 4 equals 0. So x squared is negative 4. Taking the square root of both sides, you have a square root of a negative. Imagine that negative comes out front and becomes an I, and the square root of 4 is 2. So x is plus or minus I times 2. Better way to write that is put the 2 in front of the I. So x is plus or minus 2i. And here, x equals 3/2. In numbers 5 through 9, we're asked to use the rational root theorem to solve these equations. So first of all, what we want to do is list all the possible roots. That way we know which ones we're looking for when we graph our polynomial. So we would have plus or minus p over q. It's going to be plus or minus, and then p is all the factors of the constant term. So factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. We have a lot of them. Factors of the leading coefficient is just 1. So that actually makes that a lot easier. So basically, everything you see up top are all your possible roots. So next what we want to do is we want to actually graph this to figure out which ones we should have. So pull up your TI calculator on your computer, go to y equals, and type in your equation. Hit graph. We might need to adjust the window if it's too hard to see. But actually, I can see pretty clearly. It looks like 2 is a root. So you could go to calculate, which is second trace, and then use a left and right bound to actually figure out what that root is exactly. Or we can take a pretty good guess it is 2, and when we do the synthetic division, as long as we have a 0 remainder, we'll know that 2 is correct. So let's try that approach. So I'm going to go ahead and divide 2 into 1 for the coefficient on x to the 4th, 0 because we're missing an x cubed term, negative 6, negative 8, 24. So we'll bring down the 1, multiply, you get 2, add, you get 2, multiply, you get 4, add, you get negative 2, multiply, you get negative 4, add, you get negative 12, multiply, we get negative 24, and add, and I get 0. So now I'm left with this cubic polynomial at the bottom. Now that we're left with the cubic, we can't factor quadratic at the bottom since we don't have a quadratic. So that should be a hint that there actually is another root. Now if you look at your graph, you only see the 1. But let's remember what we know about multiplicity. Because the graph rebounds at 2, that implies that 2 is a double root. So we're actually going to go through the synthetic division again with 2. So put your 2 out front, and let's repeat the process. Bring down the 1, you get 1. Multiply, you get 2. Add, you get 4. Multiply, you get 8. Add, you get 6. Multiply, you get 12. Add, and you get 0. So this is our quadratic quotient at the end. So now we can solve this for the other roots. So I'm going to hide the calculator so we have more room. So we have x squared plus 4x plus 6 equals 0. Now if you guess and check the factors of 6 add up to 4, you're not going to find any. Your options are only 1 and 6 or 2 and 3, and they don't add up to 4. So that's a hint that we need to use the quadratic formula. Again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize that formula, so take the time to learn it if you don't already know it. A, b, and c are simply your coefficients in front of each term, going left to right alphabetically. So b is 4, negative 4 plus or minus the square root of 4 squared, and I'll just mark those off in case you're wondering. 4 squared, 16, minus 4 times 1 times 6, I'll just write 4 times 6, over 2 times 1, so 2. So then I'll get negative 4 plus or minus the square root of 16 minus 24. 16 minus 24 is going to be negative 8, and that's over 2. So a couple things are going to happen. We want to bring out that negative, and we're going to get an I. Also, we're going to bring out the perfect square factors of 8. 8 is 4 times 2. So the 4 also needs to come out, and it'll become a 2 when we bring it out. So we'll end up with negative 4 plus or minus 2i root 2, since that's what's left under the square root. And we have the 2 in the denominator. Now, since the 4 and the 2 are both divisible by 2, you can actually divide them by 2. So we'll end up with negative 2 plus or minus I root 2. So this plus x equals 2, which we found from our graph, those are our solutions to this equation. All right, one more problem. Number 11 asks us to factor the equation and then sketch the graph. So, if we look at this, it has an odd number of terms, groupings out, and we can recognize there is a constant term in x squared and x to the 4th. So this is a quadratic form. I'm going to try doing this without the substitution. If you need to use the substitution, by all means do that. But I'm just going to jump right ahead and start factoring. To get started with factoring, it helps the leading coefficient is positive. So let's first take out a negative. When I take out a negative, all the signs will change. And now I can factor the quadratic. So instead of x and x, it's going to be x squared. But just like a quadratic, I'm looking for the factors of 24 that add up to negative 10. So right away, I know they both have to be negative since they multiply to a positive but add to a negative. And those factors are going to be 4 and 6. So now I have to take each set of factors, set them equal to 0, and solve for x. So from the first one, I would have x squared minus 4 equals 0. So x squared is 4, which means x is plus or minus 2, once I take the square root of both sides. For the second part, I would have x squared minus 6 equals 0. So x squared equals 6, so x equals plus or minus the square root of 6. So yes, that's not a nice number at the end, square root of 6, but that's all right, we can still graph it. So those are our 4 zeros. We have 2 and negative 2, and we have square root of 6 and the negative square root of 6. So if you're trying to figure out where to graph that, just keep in mind that the square root of 6 is going to be between the square root of 4 and the square root of 9. Square root of 9 is 3, square root of 4 is 2, so it's somewhere between 2 and 3. That's close enough. So somewhere between 2 and 3, I'm going to move it just a little closer to 3 so it's easier to see. Those are our 4 zeros. They're all single roots, so they're all going to cut through. Let's also think about our end behavior. So it's already written in standard form to begin with. Because it's negative, that means the right side goes down. Because it's an even degree, that means the left side matches. So the left also goes down. All right, and last thing we should think about is our y-intercept, since that wasn't already a 0 of our graph. So the y-intercept is what we get when we plug in 0 for x. So our y-intercept is actually going to be negative 24, which is way off our graph. So we'll just approximate. All right, so to graph this from the farthest rate, 0, it goes down, because that's our right-hand behavior. Then it cuts through. At some point, it has to turn around to go through the next 0. Then it goes way far down, negative 24, just to scoop it down here. Goes through negative 2. At some point, it has to turn around so it can go through negative 3. And then we check, did we actually end up with the other end behavior that we said we would? And we did. So we're all done.